some of the points would not have been covered yesterday. I will cover it now, and then I will have a small recap whatever we have done so far. This value engineering, I think I'm getting some echo. Can other people can mute it?
Hello?
Yeah, Senthil, I'm getting some echo. That's why whatever I'm speaking, I'm hearing it once. And I'm just. Is it okay now? Yeah, we can start now. Yeah. As I said yesterday, this value engineering started during the World War II, and the father of value engineering is L.D. Mills, who was working in a company called General Electric, GE we call it as, and this is the place where the value engineering had started. And the need why this value engineering started is that during the World War II, there was a need for a material substitution. During the World War II, the people were fighting in land, air, and also in sea. So in all the three places, there was some requirement because the people lost their weapons and they lost their resources and they were in a situation to find out some alternative how they can attack the enemies. So that is where this value engineering has started. And as I told yesterday, LD Mills is called as the father of value engineering, and he uses the technique called functional analysis technique, using the functions which we have seen yesterday. And also we have seen the basics of value analysis, value engineering, value methodology, and why we need to use value engineering. What are all the different types of value we have with respect to the economic value? And we have seen what is called value, which is nothing but the ratio between function by resource. In those days, it is called as function by cost. You can also redefine the value as the ratio between the performance of a required function. Instead of a function, you can also tell that the performance of a required function to that of cost to acquire the particular function. How much cost is required to achieve this function? So where this cost is nothing but the overall cost. Nowadays we call this overall cost as a resource, or it can be a life cycle cost. Life cycle cost is nothing but the overall cost, which includes men, material, labors, etc. For it can be applicable for any product or process or even a project as well. So if you want to design the best value, then we need to have the best cost target. So designing for the best value is the same as designing to your cost target. So we have seen what is called desirable value and what is called undesirable value. So we should always follow the desirable value. And I have compared the Tata Nano with Lamborghini car. That is how the perception of a customer is also taking place. We should not do the cost reduction such a way by cheapening the product. We should create poor value to the parts. So coming back, as I said, the value is defined as the ratio between function by resource. Resource includes the various form of aspects like men, material, energy, space, time, etc. And how you can define the function. The function is nothing but the intent or a purpose that a product, process, facility, system, or service is expected to perform such that it meets the need or want of the user. What is the need or what is the want that the particular product or process is meant for? And also it makes that item or service to make sure that it will work or it will sell. So here the function, the key aspect here is all the things a product, a process or facility or system or service it must do to satisfy the customer in terms of the performance, reliability, quality, durability, etc. So when identifying any function, yesterday we have seen some of the function with verb and noun combination. So the key questions that the customer will ask or anybody will ask is what does it do? What does that particular product or process or facility or system will do? So we need to achieve the main purpose. So hence I can define the function as the purpose or intent that a product is expected to perform such that the product will meet the need as well as want of the user. What the customer want and what the customer need, both this should be satisfied by the particular customer. And also the function should also make sure that the product is going to get sold or it is going to work or it is going to function, it is going to perform during the particular period of time or during the warranty or whatever you call. So this is how I'm going to define the function. As I said yesterday, value engineering will be a step-by-step approach. So here the main criteria what you need to look into is you should achieve the value by maintaining the performance, quality, reliability, safety, and also the environmental norms. So the value engineering here it aims at achieving the desired function. We have seen the definition of function last slide. The main objective of the value engineering or value methodology is to achieve this desired function of products, process, service, and system at minimum cost or at a minimum optimum resource giving maximum value. So we have seen the value engineering having 4 pillars. It is a step-by-step approach. It involves multidisciplinary team. It's a function-oriented, and it also involves creativity and innovation. So there are some facts about function, which is very important to note. What function is nothing but what the function is the customer is buying. What function does the customer really want and what he needs it. This needs to be fulfilled by the company. And the company should also identify what functions that the customer are not do not want or that is not been appreciated or it is not required by the customer. And the company should also look at the function like in such a way what cost effective the company can provide a particular function. Say for example, we can take the example of the cycle. The cycle is not having the seat at the back, whereas it is having the ladder at the front. This is the requirement of a customer. If suppose the customer wants the seat at the back, or if the customer do not want the seat either at the back or at the front, and if they want only the driver's seat, then the company who is going to manufacture this cycle should meet the required function or the required features what is being expected by the customer. So the company should always look the function with respect to the customer point of view, what he really wants and what he really needs, and if particular aspects or features is not required, or if it is not appreciated by the customer, and if the company is providing the extra features, then it adds additional unnecessary cost which the customer is not willing to buy, which is which the customer is not willing to pay for it. Instead buying, I can say, is not willing to pay for it. It will add additional cost, and it will also increase the cost, which can create lesser value. So this is the fact about the function. So this is very important with respect to the company point of view. The company should understand what the customer is going to buy and what they really wants, and what it is not required also you need to understand. It's not that the company will always look or need to look only what the customer really wants, and it is also mandatory what a customer do not want also needs to get analyzed. Otherwise it will also increase the cost, and additionally the customer is going to pay additional cost, which in turn is extra resource which is not required. So as I said yesterday, the function should be defined with one verb and one measurable noun, active verb and measurable noun. The function of the washing machine here is to clean fabric, which is the active verb plus the measurable noun. So here, even the value can also be improved by other means. There are different ways where you can improve the value in the company. So in any company, you can increase the value by reducing the risk for any project. If you are reducing the risk, then obviously the value is going to get increased. And you can also increase the value by improving the schedule or delivery of the project. If I reduce my lead time, and if I improve the schedule, and if I'm fastening the delivery of any project, then the time, with a limited time, I'm going to deliver it in a more effective manner. Here the key aspect you need to look into is the company should ensure that they're not going to compromise on the quality point of view, because it's not that you are going to launch the project with very fast time, but the company should also look into the aspect of quality, because quality, the time and the cost will have a equivalent impact.
You mean to say that for any type of improvement projects in a company?
One second, sir. One second. I'm getting very feeble noise. 1 second. Yeah, can you ask the questions now?
Yeah. So with this slide, what I understand is for any improvement project in a company,
okay,
this methodology approach can be deployed. Is that right?
Sir, 1 second. Actually, still the voice is. Yes, sir. Can you ask now?
What I asked is, by seeing this slide,
okay,
any project in the company can be achieved through this value management approach. Is that right?
Yes, you are right. Yeah. In specific, you are asking the second this line alone, or like you are asking the complete thing?
By looking at this various spectrum of the scope of this value engineering, it is covering everything. It is covering production. It is covering safety, health.
Exactly. Yes, it is not limited to one particular area alone, but even the health, safety, environment is also playing a vital role. Because for if in case any issue comes to the operator, then if in case any accident are happening during production, then that will also reduce the value, because it will lose the productivity. As a result of that, the production gets stopped and the background can happen, and because of that the productivity can come down, and that will also add additional cost, which will create lesser value. So to create a good value, there should be a improvement in health, safety, and environment norms also. What you said is correct. So it's not only restricted to project or product alone, but this value engineering is applicable to production and also to other department as well. Uh, and coming back to the other ways where we can improve the value. So we can also improve the value by yearly production for a given project or a product. So reducing the lead time or reducing the delivery time, the project, the value can be improved, because the the product will come with a lesser time, and the company will launch the product well ahead of other competitors, so that they will gain the importance and also the brand image among the customer. At the same time, the company should also ensure that they are not going to compromise on the quality. So if they compromise on the quality, then the brand image and it will go down, and the value will also go down. So the company should also be very much careful that they're not going to compromise on the quality. So next thing is that the improvement in health, safety, or environmental norms are this is very much important for any given project or a product. And the next important thing is the operation and maintenance is also very important. Say for example, you have different type of maintenance in a production department. You have preventive maintenance, you have breakdown maintenance, you have scheduled maintenance, uh, and nowadays some maintenance are going to happen with the help of the computer thing also. So if you're reducing the breakdown maintenance, what happens is that your overall equipment effectiveness will get increased, and as a result of that, your productivity will get increased, and cycle time is also going to get reduced, and your lead time is also going to get reduced. But if there is more breakdown, or if there is more failure that your machine is going to take place, then what happens is that it will also increase the cost. And once if the cost is getting increased, then this will also have the high cost with respect to the manufacturing of the product also. And some or other day, there can also be an increase in the manufacturing uh, cost, because if the regular failure is happening in the machine, it can also lead to the defects for the product also. So the maintenance is very important, not only to increase the productivity or to increase the cycle time, to reduce the cycle time, but this is also required with respect to the quality point of view, because the defects of the product can also happen if the maintenance is not done properly. So hence the value can also be improved by the proper operations and also the proper maintenance of the machines in any company. And again, yesterday I given one example from supplier X to supplier Y for a piston. So the value here can also be increased by method of procurement for any project or a product. So if I'm going for X to Y supplier, where the cost of the particular supplier is lesser, and at the same time I am also maintaining the function of the particular product. So the method of procurement is also a way where we can improve the product value. And also this very important thing, the company should also evaluate the market condition. If they are not evaluating the market condition, the company cannot provide a value what the customer really wants. They need to do market survey, and also they also need to evaluate the market, and also they should also do the market research. They should do what the customer really wants, and what the customer do not want also needs to be analyzed. So hence evaluating the market condition with respect to the company point of view is very important. so that they can provide a value to the customer. And this value methodology is also having some thought process. So what is the product or process? We need to understand that. And the value methodology is dealing with the functions. The function is nothing but the basic function or the secondary function. What does it do, or what does the product do, or what does the project do, and what must it do? So this is the thought process with respect to the value methodology. And the company should also ask, what does it cost, what does the product cost, and what should it cost. So the should costing and the costing analysis is very important with respect to the company point of view. And nowadays the customer is also very knowledgeable, because they are also getting the cost details with the help of the benchmarking data which are available with the help of some internet resources. They can able to find what is the cost of one vehicle and what is the cost of other vehicle. It's not only one product, they can get any cost, because they will not get the cost breakdown, but they can get the overall cost, what that are about to get sold out to the customer. It is applicable to any product. It can be for FMCG or automobile, or any matter, that even the healthcare, some of the medicines, what you can also take those things into account. And the company should also uh, analyze the fact of function. They should also do some brainstorming session where they can improve the function in a better manner. They need to do some analysis, and they should also do some benchmark. How does the competition and how their competitor is doing it, and how better how that competitive company can do overtaking their competitor. And what are the other ways, or what are alternative, that the cost can also be reduced, or it can come down, or we can achieve the required cost at the required function. So they should also understand what are the cost of the alternatives. So other ways, like if in case if you are doing some optimization, what are the other costs involved, that also needs to be analyzed. And this is the way forward for the value methodology. And the company should also understand the advantages, the disadvantages, and also the risks involved with respect to the value methodology. So we have seen this yesterday. So this is normally the job plan that we need to follow for any value methodology project or any product. Yesterday we have seen three phases. One is the pre-workshop phase, next one is the workshop phase, and the last one is the post-workshop phase. In pre-workshop phase, we collect the information. This information will be with respect to the inputs pertaining to the particular product or the process or project, and also it can be also some inputs with respect to the DFMEA, or it can be a quality inputs, or it can be a marketing inputs, or it can also be a procurement inputs. It can also be a benchmarking inputs. So all these things you need to do some study the pre-workshop phase with the help of the cross-functional team, and also with the help of some top leaders, and also the help of the top management. So normally you need to do this activity 2 weeks before you start the workshop, like 3 days workshop. Normally even the trainer of the value engineering, they do this one. So when they go to any company, they will ask the participants to carry out this pre-study activity. They will take some examples, and during the workshop of 3 days, they will mostly they focus on the workshop phase of 6 phases, which includes the information phase, next to the function phase, the creativity phase, evaluation phase, and then development phase, and finally the presentation phase. So they try to do some live examples, case studies, considering all the 6 phases. So after this workshop phase, if the ideas are being accepted by the top management, then the decision will be to implement the ideas, and then afterwards the follow-up will happen, and finally they will get the results. If in case of the top management is not agreeing, if they are not giving go ahead, then again you need to evaluate or you need to do some prioritization, or the project can also be get dropped. So to avoid the situation of no or dropping situation, what we need to do is that we need to involve the top management right from the pre-workshop phase itself, so that they will understand the top management who are there, who will be there in the presentation meeting, will be there in each and every stages, and they will understand what is going to happen, what is happening in the idea generation phase, and they will also get participated in the evaluation phase, and they can understand whether is that ideas can be taken further for development or not, and they can also reduce the cost, or they can avoid testing the ideas, and they can also avoid wasting extra resource if in case if they found that the idea is not viable with respect to cost or with respect to technical point of view. uh, so with respect to financial aspects and also with respect to technical aspects, the top management will decide the ideas can go ahead for implementation or it can be dropped, or even the ideas can also be re-evaluated. So this is a job plan that normally the company will have to do, and we have seen some
Hello.
of the yeah.
One question. What do you mean by lean inputs?
Lean inputs in the we always follow the lean manufacturing in the case of manufacturing technology. So here the lean inputs is the micro level inputs, what is required, and like say for example with respect to products, if you take it can be the volumes, or it can also be the manufacturing process, or the current suppliers, or micro level inputs. Rather than lean, it's also the micro level inputs. There's the basic inputs, whatever is required.
Okay.
Yesterday we have seen some of the functions of the cup, which includes one verb and one noun. These are some of the active verb and measurable noun for a products. So based on this, you need to select the verb and noun combination. Even I have sent one book today in a PDF format. You can get lot of examples in that book. And this is the verb and noun combination for processes. And this is for a projects. Yeah. So maybe I can give some examples. Normally the FAST diagram, which is nothing but a functional analysis systematic technique diagram. It looks like this. It is having in the left scope line and this is having the right scope line. Before left scope line, we have the higher order function, following which we have the basic function. We follow how analysis from left scope line to the right scope line, and from right scope line to left scope line we follow Y analysis. So yesterday we have seen some of the examples. So basic function always starts first, followed by which the secondary function, following the how analysis. So this path is nothing but a critical path. And we also have the design project objectives. Yesterday we have seen, and we also seen the one-time function, all-time function, and some functions will occur simultaneously. So those functions will follow the when technique, and this is also called a simultaneous function. As the function is going to happen at the same time, it can also be caused by with the help of some other functions also. So the project scope is always lying between the line of left scope line and right scope line. So the costing or any resource allocation will happen only for the function which is going to lie between the left scope line and right scope line. Higher order function and lower order function will not have any resource, and the basic function to that one which is going to lie before the right scope line will have the resource. I'll give some examples of different products. First, I will start with a screwdriver. So what does the screwdriver do? So it delivers torque, it transmits torque, it also withstands torque, it also receives torque. So these are the various functions. Okay. So what is a basic function? We always need to start the basic function. So how I am going to define the basic function? The basic function is nothing but a function which is very important, and when this basic function is taken out from the particular component, the existence will be a problem. So say for example here, the basic function of the screwdriver is to deliver torque. If I take away the basic function of delivering torque, if I take away this function, then the existence of the screwdriver will be a question mark, or it will become a stake. So achieving the basic function is very important, and all the companies should also must focus to achieve the basic function. It's not a thing, but the function is very important. Next, what we have to do is that you need to list down what are all the different components in the particular product. It's not only applicable to screwdriver; it can be any product. You need to list down the different components, sub-components, or you call bill of material. You call different sub-assemblies or different sub-parts. You need to list down. So here the screwdriver is having the blade, handle, pin, and sleeve. And next, what you have to do, if in case still any subdivisions or sub assemblies are there, then you need to look, you need to note down those things also. And unfortunately, there is no additional sub assemblies in the screwdriver. And again, the next step, what you need to do is that you need to find out the different features of the screwdriver components. So here, the features of the blade, and then the features of a handle, and the feature of a pin, and feature of the sleeve we need to identify. It is having different the diameter, length, hole, plating. It all comes in the blade, and similarly you need to find out for other features also. So I'm going to define like this. This is the component. Totally 4 components are there. The first one is the blade, and what the blade will do. You need to list down all the functions, all the possible functions you need to list down. So the blade will deliver torque. It will also shoot slot. It will also extend torque. It's also required to ensure approach, to transmit torque, to prevent rest. Because the plating is there, we need to do plating to prevent rest, and we should also allow pin for which the hole is required. So even the feature will also come into picture. This is the micro level of creating the functional analysis. It may be difficult initially, but if you take more examples, it will be easy for you. And again, this syllabus, this is not going to get covered in the VMF1 or value methodology fundamentals 1, but still I want to cover this one because most of us are working, and this is very important. We no need to wait to undergo separate training called VMF2, which is required, but before that, it's better to get some knowledge out of it. And these are the micro level things that normally we need to do. And this is the overall component parts having blade, handle, sleeve, and pin. And these are the different features. We have seen the features of a blade. You can also see the features of a handle. So the handle should have a proper shape because to receive torque. So you need to define the individual function. Say for example, the basic function of a blade is to deliver torque, and the basic function of a handle is to receive torque. The basic function will vary from individual subparts to subparts, but the overall basic function we need to see, and overall basic function we need to put in the fast diagram. So the other features of the handle includes the varnishing, which is required to protect wood. Protect is a verb and wood is a noun. And the other part is the sleeve. The basic function of a sleeve is to prevent crack. Is a basic function, and you can achieve the sleeve by creating it a proper shape. You also have a hole in it because you need to allow the pin, which is a secondary function. S stands for secondary, B stands for basic, and you also have a pin. The pin join the components, so it's a verb and noun, and also it also withstand the torque. So you need to find out such a way you're not going to miss any part. You're not going to miss each and every individual functions also, and you need to say whether it is basic function or secondary function. And the next step how you can take it further is you need to group the functions with respect to the components parts. So as I said, we have four parts in a screwdriver. Against that particular four parts, we have different functions. We need to group which functions belong to which parts. So the blade is having the functions like delivering torque, shooting the slot, withstanding torque, ensuring the approach, transmitting torque, preventing rest, allowing pin. And similarly, the handle is having the different function, and sleeve is having the different function, and pin is having different function. So you need to summarize in a micro level which function belongs to which parts, and then you have to go for a first diagram. Okay. So I'm following how analysis. So the basic function of a screwdriver is to deliver torque. How to deliver torque? So drive screw is the higher order function. It is out of scope. It is not my scope. The basic function of a screwdriver is to deliver torque. How I'm going to deliver torque? By transmitting torque. How I'm going to transmit torque? Or it's a when approach. When is nothing but a simultaneous function. So I'm going to deliver the torque by providing a slot, or I'm going to achieve the transmitting torque function by ensuring the approach. It's all simultaneous function. When I'm approaching it, when I'm ensuring approach function, then the torque is also getting transmitted. When I'm providing slot, then the torque is also getting delivered. These are the simultaneous function. And when I'm transmitting torque, the torque is also getting withstand. So how I'm going to transmit the torque? By receiving torque. How I'm going to receive torque? Or when I'm preventing, when at the time of receiving torque, there is a possibility that crack can also happen. So we need to prevent the crack. So preventing crack is the function, or supportive function. How I'm going to achieve the function of receiving torque? By operating the screwdriver. So these are some other functions like one-time function, all-time function. So now I follow Y approach. Y to operate a screwdriver to receive torque. Y to receive the torque, but to transmit torque. Y to transmit torque to deliver torque. So my scope of the project always lies between left scope line and then the right scope line. So this is nothing but the functional analysis systematic technique diagram. This diagram we call it as a fast technical diagram, technical fast diagram. We also have a customer fast diagram, but most nowadays we are following only the technical fast diagram. Yesterday I given the example of a retractable ballpoint pen. The basic function is to mark object. So normally any product will start with the function analysis. You need to for each and every individual parts you need to understand, you need to write down what is the basic function, what is the secondary function, or what are different types of functions. You need to randomly you have to categorize, or you need to organize the function, and after organizing the functions, then you need to put it in the fast diagram. So yesterday we have seen the basic function of a ballpoint pen is to mark object. We follow how analysis from left scope line to right scope line, and we follow Y analysis from right to left. So we have seen the example of the ballpoint pen yesterday. So now what will happen after creating the fast diagram? What is the next step? So the next step here is the cost function worksheet. After creating the fast diagram, you need to do the cost function worksheet. What is that? What is the ingredients in that cost worksheet? Is that you need to list down all the parts of the product. This is the product of a pen, which includes different sub parts. It includes the upper body with thread. It includes the lower body with netting thread. It also includes the tube, storage tube, and it's also having the roller ball in it. It also having the plastic cap, which is a retractable one, and it is also having the clip, chrome plated clip, and it is also having spring. It is also having the packaging, and it's also having the chrome trim ring. You need to put all the things in Excel sheet. And what you need to do here is that with the help of the costing and the sourcing team, what you have to do is that you have to put the individual cost of the individual subparts, and also you need to put the overall cost. What is the overall cost? And here you need to always look into the aspect that it is not mandatory to include all the 100% of the cost. So here they have included only 91.50% of the bill of material cost. They have not targeted 100% costs. Even if the company can also target 100% cost, but uh, based on the cross-functional team, the other costs might be very less, and they would have neglected it at the start itself. But it's good that if you're going with 100% is also good. Even if you're going with 80% or 90% is also a good one. But again, this call should be taken by the cross-functional team or the expertise or the top management or the leader with respect to the each and every department. So here you need to understand each and every individual cost of the individual part. Then what you have to do is that you need to put a cumulative cost percentage. So here for upper body thread, I'm going to spend 32.8% cost. So cumulative is nothing but the formula is here is the overall percentage cost with respect to the individual cost. So you here the 32.8% will be contributing for the upper body with thread. So again, you need to you need to list down the cost from higher cost to the lower cost. You need to list down the cost such a way higher to lower. So it will be easy for analysis also. And similarly, the cumulative also goes from higher to lower. And sometimes this will also help to target where we have to target more. And after this, what we have to do is the next step is very interesting and also quite analytical one. So next is nothing but the cross cost versus functional worksheet for a ballpoint pen. So again, you need to list down all the subparts in the Excel sheet, and you need to list down the cost of each and every individual subparts. And what you need to do here is you always need to put 100%. Now you need to do the cost analysis with respect to function. So cost function worksheet. So as the name indicates, cost function worksheet. So you need to do the analysis of your cost with respect to the function. So for me, $0.15 is not a cost. For me, 100% is a cost. So what I'm going to analyze is I'm going to analyze how much cost I'm going to spend for each and every individual function. So you need to list down all the functions which you need to take it from the fast diagram. Okay, and even you can eliminate unwanted function from the fast diagram, which is not required. So here I'm going to take the critical part functions or the necessary function which are required for the each and every individual parts. So here, what I'm going to do is that I'm going to spend 40% of the cost for the function called transfer motion. I'm going to spend 10% of the cost for a function called enhance grip. I'm going to spend 5% of the cost for ensuring location. Again, 5% to prevent damage, and 5% for the esteem, and 35% for generating pressure. You know, the upper body with thread is meant for transferring motion, and it also having the grip in it, which holds the pen for the person who is going to use it. So the person is going to spend 10% for it. And similarly, for each and other individual other parts, you need to analyze, or you need to look what is the individual cost or individual function. So here, you need to convert from percentage to cost also. So when you multiply 0.15 with 40%, you get 0.06. Similarly, we need. Yes, sir.
This on the upper body with the thread,
Yeah.
total cost is $0.15.
Yeah.
From where we got this 0.060 for transfer motion cost?
Yeah. So here again, you need to involve all the cross-functional team, especially the sourcing, and then the costing department. You need to involve them, and also you need to involve suppliers, or you need to involve the expertise. And again, this is not a exact. Sometimes it can also go wrong if you are not involving the correct person. If you are going randomly, then it can go wrong. But to get a more accurate answer, even I can say this is not that much accurate, but to go for accurate result, you need to go with the expertise. The expertise here is, in a company, you will have the costing team, you will have the cost modeling team, you have the sourcing team. They also interact with the suppliers, they also interact with vendors. uh, they know the look and corner, how they also go for a micro level cost analysis, like how we go for the micro level technical analysis. Similarly, the costing team, and then especially the sourcing team, they will interact with the supplier, and they will also see what is how much really the supplier is spending for it. Sometimes again, you,
So, in, can I understand this way that this cost $0.15 is very much available with the costing team, but
yeah,
however, with respect to each function part of it, we
okay,
need to arrive at this 0.060 or 0.015
yeah,
through based upon our brainstorming and discussion with other team members, and it is almost approximation with respect to the cost of the function. Is that right,
exactly,
sir?
exactly, sir. Exactly, you're right.
Right. Okay.
And
Thank
again, even if you use the expertise, still the percentage can go slightly wrong, but it will not go to the maximum wrong side. But again, this is also sometimes it's approximate method only. Sometimes when I say 40%, to arrive at 40%, you need to involve a lot of expertise. So you need to use the correct relevant person. If in case if the expertise is not available, then they can't give you the correct percentage as 40%. They may give some 30 or 35%, where there is a possibility that slight change in the percentage can happen. But it's always good to go for a brainstorming with the help of the expertise in each and every department. And the, the, the percentage will not deviate too much, unless otherwise the expertise is lagging. Yeah. Similarly, we need to go for each and every individual parts. And the next step, what we need to do is we need to add the cost vertically. So for the transfer motion, I'm going to spend 0.12%. And for enhancing grip, I'm going to spend this much 0.05. And again, I'm going to put it with respect to each and every individual functions. So finally, what I'm going to do is that I'm going to rank the top three, which is contributing to the more cost. So here, 0.12 which is contributing 27% of the cost, goes to transfer motion. And the second ranking is to prevent damage. I'm going to spend 15%. And sorry, for generating pressure, I'm going to spend 0.08. And for preventing damage, I'm going to spend 0.07, which is contributing 15%. So when I'm adding 27 plus 15, 42 plus again here 20, so again 62%. So if I concentrate on the top three functions, I can reduce 60% here. So rather concentrating on all the functions, if I concentrate on only the top three functions, then I can reduce 60% or 80% of the cost rather than concentrating on the complete the other functions. So this is one way where you can take it further for creating ideas, which is the next phase. So, and you can further develop, you can create ideas uh, to reduce the cost or to create more number of alternatives, how the cost of the transfer motion can come down from 0.12 to whatever the value you can come down. So you need to create more ideas how you can reduce this the function, how you can reduce the cost to achieve the function. Similarly, you can also create a lot of new ideas to generate pressure, and also you can create new ideas to prevent damage. But nowadays, the correct procedure is that it's not only to target one, two, three items, but it's always good to create ideas for each and every individual functions. And sometimes if the product is involving more complexity, then going with the top three is good. And if the product is less complex and it's easy for us or easy for the company to create more ideas with respect to each and every individual functions, then it's always advisable to go for each and every individual functions rather than concentrating on a Pareto analysis. So 20-80 percentage. So here what we are doing is we are concentrating on a Pareto sheet. Like if we concentrate on 80% of the cost, then we can achieve. It's like 20% of function. So when I'm taking the top three, it is nothing but the 20% function, which is taking 80% of the cost. So we follow the Pareto analysis here, or Pareto technique. Even that is also good for a complex product or process or project. But uh, if uh, if the process or a project or a product is less complex, then it is always advisable to go for a new ideas for each and every individual functions rather than going for a top three alone. And similarly, if the product is less complex, then it's always good to go for a cost analysis to include all the cost to 100% rather than 80% or 90%. So it's always good to go with 100% cost, and it's always good to go for a function idea generation, including all the functions. I will give another example, quite interesting example. Uh, this also includes the fast diagram. It also includes the function cost analysis, like the previous example. Uh, so here, this is an example of a fuel pump in a service station. So the basic function of the fuel pump in a service station is to transfer fuel. So this is the basic function. It can be either petrol or a diesel that needs to be transferred from the station, from the pump in a petrol pump to the vehicle. So the basic function of the fuel pump in a service station is to transfer fluid. So again, higher order function, which is out of scope. Uh, why I need a fluid, or why I need petrol or diesel? I need the petrol or diesel for my combustion to take place. It's out of scope, and I follow the why analysis, sorry, how analysis. But we need to ensure that before creating the fast diagram, you need to do the random analysis, or for the individual parts you need to identify what's the functions. Then only you have to go for this diagram. I will give a lot of examples just to get an overview. I am giving some other examples. So here, how I'm going to generate combustion by transferring fluid, how I'm going to transfer fluid, by generating the movement. How am I going to generate movement? By generating pressure. I'm going to convert energy. I'm going to connect the circuit. I'm going to transfer the signal, and I'm going to apply the force. I'm going in the reverse direction, following the Y analysis. The operator operates, takes the fuel pump in his or her hand. They apply the force. Why they are applying force? To transfer the signal, and they connect the circuit, and here the energy gets converted, and the pressure is, they are applying pressure. It's not only the force, they apply pressure, and they generate movement, and finally the fuel gets transferred from the fuel pump to the vehicle. And the other objectives is to prevent leakage. It's a project objective because there's not be any leakage. They also need to maintain durability. Again, maintaining fuel. The customer or the viewer should know how much is the uh, rate of the fuel, and also they should know how many liters they have been put into the vehicle, and they should also filter the flow to avoid the impurities, and it should also resist environment, and it should also automate the payment. And all-time function here includes maintenance safety, because in a fuel pump the safety is very important, and you should also record information. It should maintain the reliability. It should also inform customer. It will inform the customer how much is the cost, um, like metering fuel. So here it also informs the customer how much is the cost, how many liter has been put into the vehicle, and it also needs to maintain the regulation. Now we have different norms, BS6 and BS4 to BS6 we have. We need to ensure that the the regulations of fuel, or the input is whatever is coming from the fuel pump is also meeting in the regulations, and it can also display the data. So here the key questions what you have to ask is what work must be done, what is the basic function that is required. So next what you have to do is you have to go for a cost worth analysis or cost function analysis. You need to list down the each and every individual sub components, and you need to put what is the individual cost starting from the highest cost to the lowest cost. So here I'm going to consider only 88% rather than going for a 100%. The overall cost is $230 or 230 rupees you can take, but I'm going to consider only 203 rupees instead of $230 or 230 rupees. And it's always, again, as I said previously, you can concentrate whatever the cost based on the uh, decision taken by the cost function team, depending upon the complexity, etc. So again, I'm putting the.
I have a question, sir.
Yes, sir.
Now you considered only that 88.3% of the total cost, that is 230. Out of 230, you consider only 203.
Yes, sir.
What may be the other cost, that 27%?
Yeah, 17. Yeah, the other cost can be, see, totally we have different components like pump, motor, pump frame. We have pump wrapper. So I will tell in a layman language, like 1, 2, 3, 4, 5, 6, 7. So totally 7 parts are being considered for 203 rupees. The other 17 rupees whatever is there, it can be 2 parts or 3 parts. It is not considered because um, the reason can be two reason. One reason can be um, the cross-functional team would have realized that there is no scope to reduce or to take the 17 rupees into account, or 2 parts into account. That can be the one of the reason. Or the second reason can be the complexity. If in case the complexity is there, it can be with respect to the manufacturing process, or it can be with respect to the suppliers, or it can be with respect to the procurement method. There are some other miscellaneous or other factors can be there. Because of that, they may not have concentrated. They would have already analyzed that, still they could not able to find a convincing answer to go for a 100%. But having said that, 203 only they consider. There is no rules that 100% can be taken or 90% can be taken. But it's always good that if 100% parts or 100% cost is been taken into account, it's good. But even if the cost is percentage is going down, it's nothing to worry. But this analysis is only based on the cross-functional team or even the top management itself. There may be some reason. Say, for example,
You mean to say that we always should try for this 100%?
yeah.
However, if it is based on the difficulty level, we can arrive at any percentage of this 80, 90, whatever.
Exactly. And even sometimes based on the experience or based on the previous analysis, they would have understood that still going for additional 2 parts which is not required. They would have concluded well in ahead. So that can also be the reason. So again, so we need to follow the same technique, putting all the parts in a cost function worksheet and putting all the required function. It's not that we are going to complete function. So whatever is required, which is contributing to the cost or which is creating the function with respect to the cost. So here again, based on the expertise, you need to allocate the cost and you need to list down which function is creating more cost. So here again, we are going with the top 3. The first function, maintain integrity, is contributing 21% cost, and the second function, generating pressure, contributing 21% cost, and the third function, prevent spillage, contributing 12% cost. So again, 21 plus 21 plus 12, 42 plus 54%. Still, you can also go up to 80%. So you can also follow the Pareto analysis, like the 20% function contributing to the 80% cost. You can go like that, or even you can go for a, as I said, depending upon the availability of time and depending upon the availability of expertise, depending upon the complexity level. This can be 100%, and even this can also be 100%. 100% in the sense you can create 100% new ideas individually with respect to individual functions, or again this also calls based on the cross-functional team. But it's always good to go for 100% here also, rather than going for a Pareto analysis of 80%. I just give some other examples. Okay, so here for a students to educate, there is a fast diagram. The basic function is to educate student. How am I going to educate student? By teaching the subject. How am I going to teach subject? By developing the course. How am I going to develop the course? By receiving the approval. How am I going to receive approval? By submitting the course work online, outline of the course, and then I need to contact the staff. So why I need to contact staff to submit the syllabus or whatever it is, and I need to receive the approval, and I need to secure the acceptance, and I need to develop the course. I need to teach the subject. Why I need to teach the subject? To educate a student. So the higher order function. This is out of scope again. So the staff and then employability is out of scope. So what is in the scope is between left scope line and the right scope line. It's nothing but from educating the student to the submitting the outline. So this is nothing but the critical part. This is the basic function. These are all the secondary function. These are all the supportive function. This is the higher order function. This is the lower order function. This is the all-time function, and this is the project objective. And you can also include the one-time function also.
Sir, is there any approach through which we can identify this higher order function and lower order function? How we identify this higher order and lower order function?
Yeah, and the first thing what we have to do is we should always go for a basic function. First, we need to identify the basic function. That is the key requirement. Okay? And then how we can achieve the basic function, we need to develop it. Like why the, so as I said, we follow how technique from left to right, and right to left we follow y technique. So after creating the basic function, what you have to do is that you always understand, you need to go for a higher order function. You need to say why you need to educate a student. It can be similarly, you can also have two higher order function for one basic function, or also you can also have two basic function for one particular product, or you can also have single function for one particular product. So first you need to create the basic function, and then you need to follow the approach, like the how approach, and afterwards you need to go for a lower order function. How you can identify the lower order function means, the lowest level, like beyond that it is nothing, like uh, it is the one which is the lower one, and beyond which still there is no additional function. And I will give some additional examples so that over period of time you can easily understand how you can create the lower order function and how you can create a higher order function. It's easy to create a higher order function because once you know the basic function of any product or anything, then straight away you can understand why or how you can achieve the basic function. So based on that you can create a higher order function. But to go for a lower order function, it may take some time, uh, depending on how much uh, practice you are doing with respect to different examples, for which I have given the book in which a lot of examples are there. You can easily understand those things. And similarly in that book, they would have given some examples with some resources. So they would also given how much resource is required for this function, how much is resource is required for this function. So that is one of the best book actually, that is being developed by several international team members. Even that is also good as a good approach. So this is a technical fast diagram of a textbook. The basic function is to guide learning. How I can guide learn the particular book by organizing the lessons. How I can organize lesson by developing the chapters. How I can develop a chapter by consolidating the subjects, follow curriculum. So you can follow the different aspects with respect to different examples. So here the objective project objective includes developing the index, developing the glossary, maintaining the durability. So all time function, it should always increase the knowledge. That should be the all time function. The binding should be good. This is the example of a projector. I will give the example of the projector with some good examples later on. I will give all these examples after some time. So yesterday we have seen the definition of a value and a worth, and there is one more definition for a value. Value is defined as the ratio between worth by cost. So when value is higher than one, it's always a good value because the worth is higher. Worth is when the worth is higher than the cost, then the value is always a good value. And if the value is less than one, it's called a poor value. Yesterday we have seen one more terminology called a value index, which is nothing but the function cost by function worth. Higher the value index, there is always scope for increasing the value for a particular product. So higher the value index, we should always look for value improvement. And value can also be defined as the ratio between worth by cost, where worth is nothing but the lowest overall cost which is required to perform a function without regard to criteria or codes. And worth can be a dynamic. It's not a static one because of the external factors. And it's also based on the customer perception. The perception of one customer may vary with respect to other customers, and that's why it is always a dynamic. And the external factor here is the customer perception, which is not same and which is not unique. from one customer to another customer. So yesterday we also seen the ratio between function cost to function worth as a value index. So when the value index is higher, there is always the improvement for a value. So we should always look for reducing the value index. To higher the value index, there is always opportunity to improve the value or to take some value engineering projects or value methodology projects in your company. So the prime use of this value index is to compare the alternatives among the system. So you also had a value gap. Value gap is nothing but the difference between the existing cost of the product or individual parts and then how much is the worth. Higher the value gap and higher the value index, you should always look for the value improvement. Yesterday I was given you the examples how you can look for some alternatives when the value index is higher.